Hello everyone, welcome to PrepFuture Learning. My name is Amit Mandal and I am the instructor for this course on Let's Learn Python and SQL from scratch. Before beginning our next lecture, just a small suggestion. For better visibility understanding, switch to full screen mode while watching the video through laptop or desktop, and if watching through mobile phones, watch in landscape mode and turn on the captions. So far, we have discussed Python introduction, what is Python IDE, script mode and interactive mode, what are tokens, five types of tokens we discussed, that is keywords, identifiers, literals, then we have punctuators, then we have separators. So then we in tokens we have discussed keywords, and operators are in progress, and in operators we have discussed arithmetic operators, assignment operators, comparison operators, and logical operators. So who have missed these two lectures, you can go back and just go through these two lectures and then again come back to this lecture number 3. So starting with our lecture number 3, we have membership operators. The membership operators check for a membership in a succession, such as a string, list, or tuple. Like in membership operator that fetches a variables, and if the variable is found in the supplied sequence, evaluate to true, otherwise evaluate to false. So basically it means there are two types of operator we have in membership, like in or not in. So in operator returns true if a sequence with the specified value is present in the object, and in not in returns true if the sequence with the specified value is not present in the object. So to understand this in better way, let's move to our Google Colab. So I have opened this one. So first I will rename this as lecture 3, module 1, and it's our lecture number Python basics. So we are discussing membership operators. And here we have in and not in. So first discussing this in operator. Suppose we have one string, hello Python. So just remember, it's a very sensitive thing. So if I type print h in hello Python, so here I'm using the in operator, so it is highlighted in blue color. So if I press shift plus enter, so I will get this. So it's connecting. So the result will be either true or false. If small h is present in hello Python, then let's see what is the result. So it's true, yes. So since it is case sensitive, if we try to print the same command, and instead of small h we try to find capital H, So the output will be false. So let's try some more. If we try to find capital Y, so we have a small y there but not capital Y. So the result should be false. But still, let's execute the program. So it's false. So so we can say that the letters are case sensitive, and in operator helps in finding the whether this particular word is present in the string or not. So if we try the same thing with not in operator, so it will give us the exact opposite. So if I try to copy this, and instead of in, if I write not in, previously it was returning false. Let's see whether in this case it is returning false or true. So it is returning true. So y is not in hello python, the capital Y is not in present this. So in this way we can find whether a particular string, particular letter is present in the string or not. So just try one more example. If I try to find print z, whether key capital or small z, it will return true only. So z, small z is not present in hello python. So this is the membership operator we have. Let's go back to our presentation. So identity operators. When comparing the memory locations of two objects, identity operators are used. If two variables point to separate objects, it doesn't return true. Otherwise, it returns false. So in identity operator, we have two operators, is or is not. So it returns true if both variables are same object, and is not returns true if both variables are not the same object. To understand it better, let's move to our Google Colab. So we will discuss this identity operators. So we have is and is not. Let's discuss first is. So in case, suppose we have example x equal to 50, and I write y equal to x, and if I write x is y, and if I try to print this, shift plus enter, let's see what is the result. So true. So how it is true? Because we are writing x equal to 50, then we are, and y equal to x. So in this y equal to 50, and if we try to find out the id for this x and y, let's see. If I want the print id of x, so shift plus enter, so it is, the output is some number. It is the id of the x. If I try to find id of y, it should be same. That's the reason it is giving us true value here. If you try to match the exact 11440680033158, this is the exact id of x and y. That is why here it is giving a true value. So if I write one other value z equal to, suppose we have 300, And if I write x is z is x, so if I try to execute this, I will get a false value. So, and if I try to find out the reason, so I will try to search the ID number for x, print ID, then x. So ID for x is this one, and if I try to find the ID for z, so I will just copy this and just make a small change here. So if I try to press this, yeah. So x and y have the same ID while z has completely different ID. So that is why it is returning false. So I hope you got the is operator value. And if I try the same thing with the is not operator, so that the result will be different, completely opposite. Suppose in this example only, if I try to write this is not, if I try execute this, so it is returning false. So x is equal to y, and we are saying that x is not y, so that is why it is returning false value. And if I try to write this statement again, is not, z is not y, so currently it is showing false. If I try to execute this, now it is showing a true value. So is and is not operator are completely will show different result. So this is from the your identity operators. Next we will move to our bitwise operator. The bitwise operator manipulates individual bits in one or more bit pattern or binary numbers. So binary numbers are basically our 0 and 1s. For example, if a binary XOR operator is set in one input value but not both, it copies the matching binary one to the result. So we have different uh, bitwise operators like AND, OR, XOR, NOT, then 0 fill left shift, signed right shift. So AND operator sets each bit to 1 if both bits are 1, or sets each bit to 1 if not of the two bits is 1. XOR sets each bit to 1 if only one of the bits is 1. Not inverts all the bits. 0 fill left shift left by pushing zeros in the from the right and let the leftmost bit fall off. Shift right by pushing copies of the leftmost but in the from the left and let the rightmost bits fall off. So to understand it better, let's move to our Google Colab. So now we have bitwise operator. Before going to understand bitwise operator, we need to know what is a binary number. So suppose we have a number 5. So we will first divide it by 2. So the quotient will be 2 and remainder will be 1. Again the quotient 2 will be divided by 2. Then if we divide this quotient, we will get a quotient 1 and remainder 0. And then again the quotient 1 is divided by 2. So the quotient will become 0 and remainder will be 1. So since it's a binary is a 4-bit number, so it will be like 0 1 0 1. So we can conclude that first we have to divide the number by 2, then keep dividing the quotient by 2 and keep noting the remainder number. So for in this example we have first operate our bitwise AND operator. So it is represented by this sign. So suppose I have a number a equal to 5 and b equal to 3. So in binary a is 5 is written as 0101 in binary, and 3 is represented as 0011. So if I write this result A and B, and if I print this result, and if I execute the program, the output is 1. Now moving on to this bitwise OR. So if I just copy the whole thing and just changing AND to OR is represented by simple this, and if A is 5, B is 3, and if I print A and our bitwise operator OR, if I print the result, we will get the output 7. So the operator performs the bitwise OR operation on each pair of corresponding bits of the two operands. So if our next bitwise XOR operator, if I copy this again whole, print this, so we have this XOR operator, and it is represented by this. So if I print the result by using this operator, let's see what is the output. Output is 6. So this operator performs a bitwise exclusive OR operation on each pair of corresponding bits of the two operands. So our next bitwise operator is bitwise NOT. So if I copy this whole, paste it here, bitwise NOT, it is represented as this, and if I write A this, and if I print the result, so it is represented by this field, and it's like, and in this example we will just take this one, A equal to 5. We do not require B. So if I write result of NOT operator A, execute this, so we will get a -6. So this operator performs a bitwise NOT operation which flips the bit of the operand. So our next bitwise operator is left shift. So if I copy this, this is represented as this one. And if I write this, instead of result, I will write shifted, all will be in small, shifted equal to, so if I execute this, I will get the output 20. So left shift, this operator shifts the bit of the left operand to the left by a specified number of position. Now we have the last operator, right shift. So if I copy this, So it is right shift, and it is represented as this one. So if I just change this sign, and if I print the result, so I will get the output 1. So this operator shifts a bit of the left operand to the right by a specified number of position. So these examples demonstrated the basic usage of bitwise operators in Python. Keep in mind that the actual result may depend on the bits of the integers being used and the specific representation used by the Python interpreter. So moving back to our next operator. So we are done with the operators. So our next token is literal or constants. So what are literals or constants? So literals tokens in Python are data elements with a fixed value. Literals return a value for an object of the specific type. Python supports a variety of literals like string literals, numeric literals. So these are further three types like integer, float, and complex literals. Then we have boolean literals. Then literal collection is there. List, tuple, dictionary, and sets are all examples of literal collection in Python. So list is a collection of elements enclosed in a square brackets and separated by commas. These variables can be of any type and their values can be altered. So it is mutable in nature. Tuple, it is a comma separated list of elements or values in round brackets and also known as tuple because values can be of any data type but they cannot be modified, so they are immutable in nature. Dictionary, represented by curly braces, it is an unsorted collection of key value pairs. We will discuss in more details in upcoming lectures. The set is an unordered collection of the objects enclosed in curly braces. So next tokens we have punctuators. Punctuators are tokens in Python employed to put the grammar and structure of syntax into practice. Punctuators are symbols that are used to structure programming sentences in a computer language. Some commonly used punctuators are comma, hashtag, then backslash, then we have the first bracket that is our round bracket, then curly braces, then we have the square brackets, then at the rate, then colon equal to. So we will discuss the structure of Python program in our next lecture. So thank you for attending this lecture. See you in next lecture.